let's go to a systematic approach. Just kind of, this is how you go about solving a problem. For one, sort the information, right? I kept using the words, what information's given, what information I might need, the strategy to solve the problem, like my little plan of going from one unit to another. It might involve several steps. Then apply the steps in my setup, and then I check my answer and check to see if I have the a reasonable number for the end, and that I have the correct units, and so forth. So let's try some other problems. Here we have a child that has a mass of 67.0 pounds, and we want to know that mass in grams. So to approach this problem, there's things I need to know. What am I looking for? I'm looking for a mass in grams. That's what I'm trying to find. And then I'm also given a mass here. So that's a value that's given, and I'm looking for grams. So I'm starting out with pounds, and I'm trying to get to grams. And then here I have a list of conversions. Do I have a relationship already that sets pounds to grams? And I do. This one right here. Okay? So I have an equality that goes that for every 1 pound, it's equal to 453.59 grams. And so I'm going to set my problem up. I'm looking for a number in grams, and I'm going to start out with what's given, 67.0 pounds. Again, when I do dimensional analysis, I'm going to set up my ratio by taking the number that I'm given, and I need to cancel out units. So if pounds is on top, when I set up my equality here, I'm going to put the pounds on the bottom so the units cancel, and I put 453.59 grams on top. That way my units cancel. I'm given grams, and looking at the answer for this, we see that I will have, my final answer will be 3.04 times 10 to the 4th grams. This value here is 5 sig figs. This value is 3 sig figs, so I'm going to give my answer in 3 sig figs. All right. Let's try another problem. Here we have defined the number in seconds. So this is what we're trying to find, and we're given stuff in days. So I'm going to start out, develop my plan. I'm starting out with days, and I'm trying to get to seconds. And just think of things that you know. Do I know how many seconds are in a day? No, but I do know how many seconds are in, say, a minute, right? We know for every 1 minute, there are 60 seconds. Okay. Do I know how many minutes are in a day? No, but I can go to hours, because I know that for every 1 hour, there are 60 minutes. And I know I can go to days, from hours to days, because 1 day is equal to 24 hours. All right. So I'm going to start out with finding a number that we want in seconds, and I was given 5.00 days. Okay. All right. So I'm going to set up and get rid of days, and the first thing I'm going to do is go to hours. Days are on top, so I need to put the day on the bottom, and the other side of the equality goes on top. So I got rid of days. I have hours, and then I'm going to go to the next equality here. So I have hours on top. I need to put the hour on the bottom, and the 60 minutes on top. And I'm not quite done yet. I got hours, but I want to go all the way to seconds. So I'm going to set up my third equality, where I have the minute on the bottom, the 60 seconds on top, and I'm got rid of my minutes, and now I have seconds. I multiply these together, and I get an answer of 4.32 times 10 to the 5th seconds. Now here, this happens to be 3 sig figs. There is exactly 24 hours in a day. There's exactly 60 minutes in an hour, and there's exactly 60 seconds in a minute. Now, not every one of these equalities are exact. Most of these are not exact. The ones that are exact are labeled here. The only one that is exact is this 1 inch to 2.54 centimeters. But these time conversions in the English system are exact. All right, let's try another problem.